अच्छा कोई स्पेसिफिक पेपर भी करना है लेट मी नो, ठीक है। क्वेश्चंस वगैरह वो भी बता दो अगर स्पेसिफिक क्वेश्चंस है। अच्छा ओ we will try and do things अच्छा we'll try and do things quickly, ठीक है। इसके अंदर ना बस बहुत ज़्यादा डिटेल में कैलकुलेशंस नहीं करूँगा, we'll just try and do questions quickly, ठीक है। This is what this one is, I'll give it a phone। अच्छा this one is ये कौन सा है, summer W22 question paper 2-1, ठीक है। So we'll start with, we'll do the more important ones, ठीक है। We'll just quickly go through the easy ones. So starting with this question, so this one is what? It's like a lactones are cyclic esters. So under suitable conditions, lactones form from molecules that have both an alcohol and a carboxylic acid functional group. So it's obvious you've got a carboxylic acid functional group. Okay, so there is, sorry, so there's a carboxylic acid functional group and there's an alcohol. So alcohol and carboxylic acid obviously form esters. The carboxylic acid loses its OH, the alcohol loses its H, and they just join up. Okay, and they end up forming, they connect together and they form an ester. So that's pretty obvious. Now, what he's doing is that shows the synthesis of lactone P from, so lactone P from compound M. First thing, hot concentrated KMNO4. What does it do? Hot concentrated KMNO4 क्या करता है? That's
सर
oxidation.
ऑक्सीडाइज कर देगा,
किसको?
सर एल्कीन को ऑक्सीडाइज करवा देगा।
ठीक है, so it oxidizes an alkene and you've got three options. अच्छा, when you have an alkene, तो three options होते हैं कि you can double bond completely breaks. If the double bond carbon has two carbon chains, that will turn into a ketone. If it's got one carbon chain, it will turn into a carboxylic acid. If it's got two H's, then it will turn into a methanoic acid and then get oxidized to carbon dioxide and H2O, ठीक है। तो यहाँ पे I'm just going to do that कि बीच में जो double bond है ना, that's going to break. और अब you've got this carbon atom and you've got this carbon atom. जल्दी से बताओ कि what will happen to this carbon atom over here?
सर कार्बन डाइऑक्साइड प्लस वाटर फॉर्म हो जाएगा।
नहीं, ये वाला, this
सर
one,
जो पहला वाला है,
left वाला,
सर सॉरी, इसमें कार्बोक्सिलिक एसिड फॉर्म होगा।
ठीक है। If it's got one carbon chain, तो it will turn into a carboxylic acid, ठीक है। तो ये वाला जो है ना, this is going to turn into carboxylic acid. What will happen to this one? It's got two carbon chains. So ये किसमें, what will it get converted into?
कीटोन।
ठीक है, so that's going to get converted into a ketone, ठीक है। अच्छा, so that's N. N here. Draw the structure of N. So that's this. Then what happens is that he uses NaBH4. What does NaBH4 do?
सर रिड्यूसेस।
किसको, carboxylic acid or ketone? What does it reduce?
नहीं सर, कीटोन को करेगा।
ठीक है, remember कि NaBH4 and Li, carboxylic acids also get reduced, but they get reduced by LiLH4, not with NaBH4. So aldehyde and ketones are going to get reduced by NaBH4. ये भी NaBH4, they'll turn back into an alcohol. तो यहाँ पे क्या होगा, the molecule, ये वाला जो part है ना, the double bond O part, that turns back into an alcohol. तो वो जो एक end है ना, that's carboxylic acid, that remains as carboxylic acid. The other end just turns into an alcohol. That's it. अच्छा, फिर there's some reaction P as well, reaction number 3, which we don't know what it is. So construct an equation for the reaction 2 using molecular formula. So reaction number 2, ये वाला. So, and he's saying कि 5-hydroxyhexanoic acid, ठीक है। तो use H, तो basically you have to write an equation for this. तो N क्या चीज है, that's a carboxylic acid. ये क्या, that's CH2. Then there's another CH2. Then there's another CH2.
class है।
ठीक है, there are 3 CH2s. उसको बल CH2 करके भी लिख सकते हो. What you can do is you can write CH2 and bracket thrice, right? So you clear this is carboxylic acid, then there are three CH2s, then there's a ketone. वो ketone, sorry, ketone here. And then you've got this last carbon, that's a CH3. उसके लगा लो हिसाब कितने H होंगे, that's 1, 2. So that's a CH3. So that's your molecule. ठीक है, that's N. ये हमने N बनाया था. And now what happens is कि it gets reduced and it turns into this thing. So अच्छा, we have to make an equation. तो ये क्या चीज है? This is carboxylic acid again. और फिर क्या है? This is carbon with 2 H's, carbon with 2 H's, carbon. So 3 CH2s. So उसको इकट्ठा इस तरह लिख देते हैं. अच्छा, then this is, अच्छा इसमें ना H काउंट करना बड़ा मस्ट है कि make sure कि you, इसी में गलतियां होती हैं. ठीक है, so just make sure कि every carbon atom, this one would have 1 H, ठीक है, this carbon over here will have 3 H's. So then there is CHOH, and then finally there's a CH3. अच्छा, N जो है it's getting converted into this thing, and he's saying कि जो NaBH4 है ना, use H to represent one atom of hydrogen from the reducing agent. So you have to use H. वो जो NaBH4 है ना, that is being represented by H. तो बताओ, you just have to balance this, ठीक है? So how would you balance this? क्या हुआ? Is it balanced or not? Everything else looks exactly the same except कि I think यहाँ पे ना there are 2 more H's. इधर सिर्फ जो difference है ना दोनों molecules में, that's this part. यहाँ पे there was CO and over here you've got CHOH. ठीक है? So the rest of the molecule is exactly the same. So one oxygen, you still have one oxygen. Like there are 2 extra H's now. So इसका मतलब है 2 H's got added. So that is why it's a reduction. ठीक है? Very often they're going to ask you to make an equation for oxidation and reduction. Reduction के लिए ना, whenever it's an equation for NaBH4, तो हमेशा कहते हैं कि represent NaBH4 with an H. कभी कभार they ask you for equations for oxidation. उस केस में जैसा ये पहली वाली भी बना लेते हैं, they haven't asked us, लेकिन I can make the first equation as well कि उसकी भी वो कह सकता था कि make an equation for the oxidation and represent the oxidizing agent with an O. तो वो पहले वाले का भी कर लेते हैं just for practice, for the sake of practice, कि आपके पास ये था, that was your starting molecule, right? So you have to know the molecular formula of this thing. What is the molecular formula of this thing? It's इसको इकट्ठा ही लिख देते हैं. कितने कार्बन है? That's 1, 2, 3, 4, 5, 6 हो गए ना. So that's 6 carbons. H कितने हैं? That's 1, 2, 3, 4, 5, 6. इधर एक होगा 7, 8, 9, 10, right? So there are 10 H's. That's it. C6, H10. ठीक है, गौर से H काउंट करने हैं. तो अच्छा, ये Just hold on 1 second. अच्छा आवाज आ रही है? हेलो? हेलो?
Yes, yes.
अच्छा ठीक है, कोई अगर नहीं अभी मीटिंग में ऐड हुआ हो ना, वो मुझे उसमें, अच्छा फिर वही हो रहा है. अच्छा, so this one, okay, I'm just trying to make an equation. अच्छा, I'm just trying to make an equation for oxidation of this thing. C6H10, okay, that's H10. And it's going to get oxidized. So oxidation ke baad, what was the product that was formed? The product that was formed was, what double bond was broken, okay, it was broken and it turned into a carboxylic acid, and this part turned into so this part turned into a ketone. So I'm just going to do that. Okay, so it's going to be carboxylic acid. फिर आपके पास you got CH2, 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 3 CH2s. फिर यहाँ पे there was CO. And then there was, so then there was CH3. So if you look at this equation, what is happening is that the equation is not getting balanced. Okay? The oxidation equation, if they ask you, कि भी oxygen add करके ना, make sure you make a balanced equation for the first reaction. What is now happening is, so what is now happening is, the equation is not getting balanced because उसमें ना you need, the H's are not balanced. Okay? There are too many oxygens over here. इसको जरा total करो कितने oxygens आ रहे हैं. That's 3 oxygens. H's कितने हैं आपके पास? That's 1, 2, 3, 4, 5, 6, 7, and 3, 10. अच्छा नहीं, H's balance हो गया. That's it, 3 oxygens.
Sir,
Yes.
sir, I was just doing exercises for stoichiometry, and sir, you know the combustion analysis equation?
Yeah.
Sir, like, do you always use it in case of like like other cases other than alkenes? Like, can you use it in case of aldehydes, or just for alkenes and alkanes?
You can use it for any hydrocarbon.
Okay.
अच्छा खैर आगे जल्दी से move करें. Why does reaction 2 create a mixture of 2 organic compounds? Reaction 2 is nucleophilic. Nucleophilic addition. अच्छा, now this reaction number 2. ये जो reduction था, ठीक है, this is, ये एक important question है. Why does reduction create a mixture of 2 organic products? So what was happening in reaction 2? You had a ketone, and that ketone was getting reduced by NaBH4, and it was getting reduced to NaBH4, and it was turning into an alcohol. So reduction, remember, normally reduction of a ketone to an alcohol, it just produces an alcohol. That's about it. So you have a big important question, okay, why is it producing 2 organic compounds? So you have a simple ketone. Oh, ketone कहाँ पे था? It was on the, उसके बाद there was a CH3 as well. Actually, I had a simple ketone like this. It underwent a reaction with NaBH4, and ketones, they get reduced and they turn into alcohols. So they turn into alcohols. तो अब ये बताओ कि if it's turning into an alcohol, why is it two different products? Chan, कोई idea?
They were completely reduced.
My simple reaction. It's a simple reaction. It was a question आनी चाहिए AS में, लेकिन अभी latest paper में it is there. ठीक है, and I'm going to explain this. You have a ketone, and it gets reduced. It turns into an alcohol. ठीक है. उसका simple answer ये कि बल्कि आ जाना चाहिए, इतना बड़ा मसला नहीं है. Why is this two different products? It's two different products.
अच्छा, सही से वो मार्किन ऑफ प्रिंसिपल उसके ऊपर लगता होगा इस वजह से.
नहीं, Markovnikov ऑफ प्रिंसिपल इसमें नहीं लगता. Markovnikov ऑफ प्रिंसिपल एल्कीन्स पे लगता था उसकी एडिशन पे. ठीक है. In this case, it's what is getting produced is a chiral molecule. This molecule over here is chiral. So इसका मतलब it's got stereoisomers. It's got two different optical isomers that are getting produced. यानी यहाँ पे ना, when a ketone gets reduced, in this particular case, the molecule that is produced has 4 different groups attached to it. So there'll be 2 mirrored versions which are going to be non-superimposable. Is that clear?
Yes, sir.
Yes, sir.
Actually, that's just one mark, okay, because you're getting a chiral product, okay, that's it. So it's going to have 2 mirrored versions, right? जो मुश्किल part है ना, which is why are you getting 2 different products when a ketone gets reduced? Why are you getting 2 mirrored versions? Why not just one of them? Why both of them? Okay. So the explanation for that is, because it's obvious, you know that this is chiral. Okay, you've studied this, and you know it's going to have 2 non-superimposable mirrored versions. What is the shape of this molecule over here? ये ketone वाला जो molecule है, what is the shape of the carbon when it's got 3 pairs of bonds? What is the shape?
Trigonal planar.
Okay, so this is trigonal planar. Okay. So trigonal planar is that it's fan shape. It's double bond O, and you've got a CH3. So a fan is completely flat. It's 2-dimensional. Okay, think of it as a fan. The fan has 2 sides. Like this, I mean, the fan has 2 sides. Like there's a top side and there's a bottom side of the fan. This carbon over here is positive. So the reason ketones undergo अच्छा reasons, ये कोई भी ऐड हो रहा है, पहले मुझे क्या उस पर वेरीफाई कर ले. एक सेकंड में मैसेज दे दूं, पता नहीं कोई आके ना बीच में ना ऐड होने की. अच्छा, and let me extend this to this part as well. Ketones and carbonyl groups, they undergo nucleophilic addition reactions. ठीक है, ये थोड़ा सा बहुत डिटेल में हो जाएगा. It's a little bit too much detail, ठीक है, but it's just for 1 mark, so it's not that important. Ketones always have this, ketones and aldehydes always have this positive carbon atom, so any nucleophile gets attracted to it and bonds with it. So that's how hydrogens get added as well. Okay, so if you have H-1, that's reduction. NaBH4, etc., produce H-1 ions, and these H-1s are going to get added to it. Now think of this as a fan. Now this H-1 can get added from the top. So if it gets added from the top, तो फिर क्या होगा? It's what will happen is that the H will get added from the top, and all the other bonds will be pushed downwards. The double bond O will be pushed downwards, the CH3 will be pushed downwards, the R will be pushed downwards as well. So that is one molecule that's going to be produced. Okay, so the H is bonding from the top. And that is what happens in reduction. और फिर वो the oxygen electrons, they get repelled, it becomes -1. So another H gets bonded to it, it becomes an alcohol eventually. The other part is that the H-1 could also attack from the bottom as well. Because another fan, it's completely flat. So it can attack from the bottom as well. And if that happens, so you'll get a mirrored version that the H can get bonded from either side, which is why you're going to get two non-superimposable mirrored version, which is why you're going to get both optical isomers. The idea clear है the first part was easy, that it's chiral and it's got optical isomers. Okay, that's easy. The second part is why is this happening? It's happening because this is trigonal planar, and the H could get added from the top or it could get added from the bottom as well. So it can get added from either side, which is why you're going to get both types of optical isomers. Is this clear?
यस सर, तो सर हम लोग इसमें कह सकते हैं क्योंकि ये सिमेट्रिकल था इस वजह से इसके दोनों एग्जिस्ट करेंगे.
इसमें लिखोगे it's trigonal planar, so the nucleophile can get added from the top or it could get added from either side. So which is why you're going to get both types of mirrored versions. ठीक है?
ओके सर.
लेकिन it's not that important. ठीक है? ये थोड़ा बहुत डिटेल में चला गया, लेकिन it's 1 mark here. ठीक है? It's not that important. ठीक है? But always remember this thing कि इसका मैं थोड़ा सा idea और थोड़ा सा explain कर देता हूँ. This is trigonal planar. You're going to get both enantiomers. If it's going to form optical isomers like chiral, you're going to get both of them. जैसा यहाँ पे भी है ना, electrophilic addition. मुझे बताओ कि although this is not chiral, लेकिन what if it were chiral? If there were carbon chains, it was chiral, right? What is the shape around this carbon atom? क्या shape है?
सर टेट्राहेड्रल.
नहीं, carbon के कितने bonds are? That's 1, 2, 3, right? So what is the shape? It's trigonal planar. It's fan shaped. ठीक है, clear?
Yes, sir.
यस सर.
So again, it's fan shaped. So the fan is going to have two sides. So the Br-1 could attack from the top and join from the top, or it could join from the bottom side as well, right? So you will get both types of optical isomers if it was chiral. It's not chiral in this case. Again, if it was chiral, you'll get both types of chiral molecules. ठीक है, the same thing. So इसके अंदर भी याद रखा कि in this case, if it were forming a chiral center, then you'll get both types of optical isomers. Same thing over here. SN1 reaction. Again, what is in this step? This is ये क्या होगा? What's the shape? It's trigonal planar fan shape, right? Is this clear?
यस सर.
So OH-1 could attack from the top of the fan or it could attack from the bottom of the fan. Okay, so if it was chiral, then you'll get both types of chiral centers. Achha, but in this one, what happens in this case? Okay, the Cl is negative. The OH-1 attacks from the opposite side, right? There's a carbon positive and the OH-1 is always attacking from the OH-1 is always going to attack from the opposite side of the Cl. Okay, Cl ये वाली side negative है, so it's going to attack from the extreme opposite side. तो दोनों साइडों से attack नहीं करेगा. It's not going to attack from both sides. It's going to attack from just one side. ठीक है? So if it's going to attack from just one side, which is the opposite side, so the OH will always get attached from that particular side. So this one will always produce just one type of optical isomer, not the other type. But is this idea clear? It's in this particular mechanism, you're not going to get optical isomers because the OH is always going to attack from the left side. Okay?
सर
हाँ जी.
सर लेकिन ऑप्टिकल आइसोमर्स की जरूरी नहीं होता कि वो चारों साइड से डिफरेंट एटम से बॉन्डेड होते हैं. तो ऑप्टिकल आइसोमर्स
मैं कह रहा हूँ assume करो कि this is chiral, right?
राइट सर.
मैं तो वो कह रहा हूँ कि ज्योमेट्री ना कि इधर क्या था? This was trigonal planar, right? Whenever it's trigonal planar, it's fan shaped. So the OH-1 could attack from the top or it could attack from the bottom. Okay? Whenever it's fan shaped. जो कि मैंने शो भी किया था, इसमें थोड़ा सा डिटेल में शो कर देता हूँ कि वो मैंने वैसे शो किया था कि फैन शेप्ड होगा, इट्स गोइंग टू अटैक फ्रॉम द टॉप, इट कुड अटैक फ्रॉम द बॉटम साइड, but when it's like this, the OS -1 is always attacking from the left side. ठीक है, तो इसके ऊपर इतना टाइम ना वेस्ट करो, ये they're not going to, it's just a 1 mark question, they're not going to ask, I mean this is the only question they've actually ever asked on this. ठीक है, लेकिन ये समझ आ गया था this part?
Yes, sir.
Yes, sir.
I said draw electron P, the product of reaction number 3. What is reaction number 3? They didn't say what reaction number 3 is. I said reaction number 3 is your ester. ठीक है, that's your lactone. ठीक है, so you've got this molecule now. So how would it form an ester, ये वाला molecule?
Sir, ये cyclic हो जाए.
हाँ, तो what will happen is कि the OH over here and the carboxylic acid on the other side, ठीक है, they'll join up. तो इसका मतलब है you got 1 2 3 4 कितने 5 6 carbon atoms. ठीक है, so the alcohol and the carboxylic acid would join up. So कितने 6, so that's 5 beach में ना, so that's 1 2 3 4 and 5 तक तो यहाँ हो गया. ठीक है, that's 1 2 3 4 5. On the 5th one there's an OH, and on the first one there's a carboxylic acid.
Sir, how do they join up? वो खुद ही से हो जाते हैं, कोई conditions होती हैं?
नहीं, वो उससे ये बताया था ना कि उससे पहले शो किया था एग्जांपल कि the carboxylic acid and the alcohol they join up and they form an ester. ठीक है, उससे एग्जांपल दिया हुआ था. ठीक है, कंडीशन उससे कोई नहीं बताई हुई, लेकिन एस्टर फॉर्मेशन की कंडीशन होती है ना, क्या होती है कंडीशन?
So concentrated sulfuric acid, heat and a reflux.
ठीक है, concentrated sulfuric acid plus reflux. और if you want to break an ester तो क्या होता है कि you dilute acid या dilute alkali plus reflux. तो P जो है ना, that's वो lactone P है ना, lactone, उससे कुछ भी नहीं बताया था, he just said it's a lactone and this was the information that was given, so you have to infer कि भाई carboxylic acid and the alcohol they join up. I said the 5th carbon atom has another carbon as well, so there's one other carbon atom hanging over here. The OH is lost, the H is lost, and they will, वो दोनों जुड़ जाएंगे. ठीक है, they'll join up. ठीक है, तो that's your ester and a water molecule gets produced. ठीक है, that's lactone P. ये clear है?
Yes, sir.
Yes, sir.
Yes.
As the next part is a student monitors the progress of reaction to using infrared spectroscopy. Suggests why it is difficult to distinguish between N and 5-hydroxy hexanoic acid. N जो था ना, वो N is this thing, वो जो ketone and carboxylic acid, and 5-hydroxy hexanoic acid is this thing. So according to infrared spectroscopy, why is it difficult to distinguish them? Because they have got the same type of bonds. Infrared spectroscopy identifies bonds. So you got a Cedal bond, or you got a Cedal bond over here. You got an OH, you got an OH, you got 2 OH groups over here. You've got carbon chains, you got a carbon chain over here. You got a CH bond, you got a, so all the bonds are exactly although they're 2 different structures, but the bonds, जो bond यहाँ पे है ना, we bond exactly वहाँ पे, ठीक है? So they have exactly the same type of bonds. So you're going to get the same absorptions, ठीक है? Why is the table given? Answer this one. इस पे आ जाओ. Remember mass spectroscopy, quick revision, quick recap. Remember mass spectroscopy, no detail is important as such. Mass spectroscopy is that it detects mass of particles. You always get a molecular end peak. Molecular end peak में you get an M+1 and M peak, right? Okay, just a quick recap. Okay, why do you get an M+1 peak when you do mass spectroscopy? M+1 क्यों आती है? Why do you get an M+1 peak?
So carbon 13 की peak होती है.
ठीक है, so if you have a molecule, let's say any molecule, CH4 है, The molecule will have a mass of 12 plus 4 hydrogens. That's कितना हो गया? 16 हो गया. Lekin carbon has an isotope which is carbon 13. So the mass could be 13 as well, plus 4 hydrogens. That's going to give you 17. So iska matlab hai the mass will increase by 1 if you have an isotope. So the ratio of the mm plus 1 peak, what does it tell you? कि उसके ratios-
कार्बन 12 और कार्बन 13 के मास के दरमियान का रेशियो.
हाँ, उससे क्या पता लगता है? If you know the ratio of,
सर नंबर ऑफ कार्बन एटम्स.
do you get, or what is the formula for that?
सर 100 over 1.1 into smaller ratio over bigger ratio.
हाँ ठीक है, m plus 1 over m. ठीक है, so that's तो जैसा CH4 है ना, CH4 can have a mass of 16. That's your m. You get 12 plus 4, that's 16. Or if you have an isotope, so CH4 could be 17 as well. That's your m plus 1. 16 आने के chances ज़्यादा है. ठीक है, most of the carbon 12 that you're going to get is 16. That's 99% chances of getting that. Or 17 आने के chances बहुत कम है. That's 1%, right? So based on this ratio, you can tell the number of carbon atoms in a molecule. So you're given the mm plus 1 ratio. तो उसको plug in करो, you'll get (3.15) divided by 95.5. तो कितना आ रहा है? What is that?
Three.
The 3 carbons, because the molecule has 3 carbons. That's one information. So there's an unknown lacton Q. अच्छा, remember mm plus 1 का आपको सिर्फ ये याद रखना है. किसी को पता तो नहीं करना कि कहाँ से है. ये clear है ना सारों को? Okay, if you're given the mm plus 1 ratio, you can figure out the number of carbon atoms.
Yes.
ठीक है. वो किसी ने अगर डिटेल पूछनी है इसकी, वो मेरे से पूछ ले, लेकिन all you have to know is this formula. Use the data to deduce the structure of Q. So there's an unknown lactone Q. So you just got 3 carbon atoms. So lactone first, he's using the word lactone, so that means it's a cyclic ester. So it's a 3 carbon atom ester. So double bond O or O. E होगा ना. There's going to be 2 H's with this one. So I've drawn.
सर
हाँ जी.
सर ओन के आने से कीटोन नहीं बन जाएगा.
नहीं, लैक्टोन की डेफिनेशन उससे पहले दी थी ना. He told you what a lactone is. क्वेश्चन के स्टार्ट में ना, he told you कि what is a lactone? Lactone are cyclic esters. And he gave you an example that this is what a lactone is. Is that clear?
यस सर ठीक है.
तो लैक्टोन का तो आपने इधर से फिगर आउट किया ना. So it's a cyclic ester. So either be is using the word lactone, तो उसका मतलब it's a cyclic ester, and we figure out it's got 3 carbon atoms. So if it's got 3 carbon atoms, so if it's got 3 carbon atoms, and I added an ester, ठीक है. अब बताना ये कि is this the right one? M क्या होती है? That's the MR, right? So is this 72 or not? 3 carbons, that's 36 plus
Yes, it is.
is 32 plus how many H's? 4 H's, right? So I think that's going to be exactly 72. Why do you have 73? Because one of the carbons could be 13, so the mass could be will have a difference of 1. Actually, let's get a mass spectroscopy. Quick revision. If the m plus 2, why do you get an m plus 2 peak, by the way?
सर आइसोटोप्स की वजह से.
किसके isotopes?
सर क्लोरीन और ब्रोमीन के आइसोटोप्स की वजह से.
ठीक है, तो chlorine and bromine will create a difference in mass of 2, because chlorine could be 35 or 37, or bromine could be 79 or 81. So if there's a chlorine or a bromine, the molecule will have a difference in mass of 2. You'll get 2 different particles, mm plus 2. Chlorine के case में what's the ratio of mm plus 2?
सर 3:1.
Okay, because chlorine 35 and 37 have a ratio of 3:1. And if it's a bromine, so what is the ratio?
1:1, sir.
1:1.
1:1. Okay. So that's your basic mass spectroscopy. You either have to figure out the number of carbon atoms, okay, or you have to figure out MM+2 ratio. That will tell you the number of chlorines and the number of bromines. Okay. तो इसका पिछला पार्ट आप करते हैं, ठीक है. Remember, latest pattern ये कि inorganic, organic, ठीक है. That's you get more of that. Achha, this one, organic compounds can be distinguished using chemical tests. So, how would you distinguish these two?
Iodoform, sir.
Iodoform is going to be negative for both of them.
सर वो हमारे पास सेकंड
हाँ, पहले तो iodoform clear कर लेंगे. Iodoform is for a methyl with a serial bond O or a methyl with CHOH. You don't have methyl. I mean, this is CH3. This is methyl, but next door there is no CHOH. Okay, there's a CH2. This one again, that's a methyl, but next door there is a CH2, not a CHOH. Is that clear?
Yes, sir.
सर वो दूसरा वाला सेकेंडरी अल्कोहल है तो इस वजह से उसकी ऑक्सीडेशन पे वो कीटोन बन जाएगा और एस्टर्स ऑक्सीडाइज नहीं होंगे.
ठीक है, alcohol, secondary alcohols, they get oxidized, so that's K2Cr2O7. Acidified reflux, मतलब reagent नहीं मांगा, ठीक है, no conditions. What is the color change for K2Cr2O7?
सर ऑरेंज टू ग्रीन.
ठीक है, that is orange too. So next one again, this is an ester and this is a ketone. क्या करोगे?
सर रिड्यूस करवा देंगे कीटोन को.
So how about 2,4-DNPH?
Yes, sir.
Because if you reduce ketones, you don't have any visible result. 2,4-DNPH will identify a carbonyl group. 2,4-DNPH is this one. It's
Orange PPT, sir.
you get aldehydes and ketones, you get an orange crystal with 2,4-DNPH, you get this one. So 2,4-DNPH. This is for A2. This is for B1. You get orange precipitate. As the next one, one is an alkene, the other one is an alkane. So what's going to happen?
सर ब्रोमिनेशन करवा दें C2 की.
You get Br2 aqueous, absence of light. So C2 will red brown color decolorizes. This and this, how would you distinguish these two? क्या होगा? Leon, Kian, क्या होगा? This got carboxylic acid, you know? This has a carboxylic acid, so this one is
Justification, sir.
which one?
Justification. Can you do that?
Yeah, you can do that, but that's like, tell me an easy one.
Carbonate.
Carbonate, carboxylic acids are acids. You can check the pH even. Check the pH. This is an acid, so it's going to be acidic, right? Carbonate, you add sodium carbonate. If you add sodium carbonate, you're going to see for D2, you're going to see bubbles of gas, carbon dioxide gas. The observation will be effervescence or bubbles. That's the next one. C1 has a melting point of 94 and the boiling point of 49. Explain these properties by referring to the type of van der Waals forces between molecules. So C1. So it's got, I think it's got a low melting and boiling point, right? Why?
सर लो सरफेस एरिया तो लो कांटेक्ट पॉइंट्स होंगे जिसकी वजह से उसका वो मेल्टिंग पॉइंट गिर जाएगा.
Nee, but what is the, as a bit, well, the type of van der Waals forces? What would you call that?
सर टेम्पररी इंड्यूस्ड
ठीक है, temporary dipole, induced dipole या instantaneous dipole, induced dipoles. Temporary dipoles, induced dipoles, ठीक है. Instantaneous dipoles, induced dipoles. So बाकी I think all molecules have the same size. So plus you can say that it have a low surface area, you can add that. Okay, longer chains have more surface area, they've got more van der Waals forces. Smaller chains have weaker van der Waals forces. Cis isomer of C2, you have to draw that. So you got a double bond. How many carbons? That's 1, 2, 3 on this side, 1 on this side. So you've got a double bond. So 1, 2, 3 carbon atoms on one side and 1 carbon atom on the other side. So the cis would be that the H's will be pointing in the same direction. And that's all your H atoms. Okay, that's your cis version. C2 forms a polymer, this one. Alkenes, what type of polymerization would happen?
Additional polymerization, sir.
Okay, you have to draw a repeat unit, so just draw the double bond. There's H, upar ke there's 3 carbon atoms, so that's I think C3H7. Over here it's CH3. Same thing would, the molecules monomers would join up and they'll form linkages. Beach में the double bond would turn into a single bond.
सर हम पेपर के अंदर पेंसिल से ड्रॉ करके तो आ सकते हैं ना?
अच्छा, पेंसिल के अंदर ना एक मसला है कि if you draw it with a, I don't think that's a problem now, because obviously they're better scanners now. Lekin pencil does not scan that well. Specifically, if you make a line, then you rub it, and then you redraw it, ठीक है, तो उसमें फिर problem ये होता है, the pencil does not scan that well. तो अगर तो just to be on the safe side, if you let's say you drew a molecule, then you erased it, and then you drew it again, so try redrawing it with a pen. ठीक है, idea clear?
Okay, sir.
That's a bit risky, sir.
Huh?
That's a bit risky, sir, drawing with a pen.
But if you rub it once, a pencil, if you rub it, then and you're redrawing it, right, on top of it, then make sure you do it with a pen.
Okay.
Pencil does not scan well if you've done too much cutting and erasing at the bottom. So that's it. So previous question quickly. So all the chlorides that have giant ionic structures in the solid state, who's got a giant ionic lattice out of all of these?
Sir, NaCl.
Maybe MgCl2 is also ionic. So all the chlorides that react vigorously with water to form strongly acidic solutions.
Sir, PCl5 or sir ACl3 होगा.
All these three.
Sir, SiCl4 के अंदर हमारे पास weakly acidic नहीं बनता?
नहीं, strongly acidic. We notes. Strong hydrolysis, vigorous hydrolysis. SiCl4, AlCl3, strong hydrolysis, they all have rapid reactions releasing fumes of HCl, ठीक है? तो
सही sir.
अच्छा, वो MgCl2,
so अब वो slightly acidic करेगा, उसकी 6.5 pH होगी.
कौन सा? MgCl2 का it's very weak hydrolysis. ठीक है, very slightly acidic, pH 6.5. अच्छा, anyways, so all the chlorides that react vigorously with water, that's AlCl3, SiCl4, and you've got PCl5. Who would dissolve in water to form a neutral solution?
NaCl.
ठीक है, वो NaCl है. It would form sodium ions and Cl ions aqueous हो जाएगा, ठीक है, that's it, dissociates. highest melting point, the chloride formed from the element, which element period C में has the highest melting point?
It's
Silicon,
I
sir.
think.
ठीक है, that's silicon. ठीक है, remember this quick recap क्या कि NaMgAl are metallic, so they've got low melting. I mean, Na is the one that's got low melting points, but Mg and Al have high melting points, strong because they've got stronger metallic bonds because of more delocalized electrons. Na is also metallic, but it's got fewer delocalized electrons, so the attraction between the positive ions and the delocalized electrons is not that strong. Silicon is a giant covalent structure. The rest are simple molecular. Phosphorus, sulfur, chlorine, argon are simple molecular. So silicon is the one, okay, because it's got strong covalent bonds, giant covalent structure. NaCl is one of the product of the reaction of chlorine. What is the reaction of chlorine with cold NaOH? क्या होता है?
सर हमारे पास NaCl plus bleach बन
ठीक है, so you get NaCl plus NaClO plus H2O. ठीक है, remember these two reactions के inorganic में करें group 17. So remember this chlorine with cold NaOH, that's going to form NaCl, NaClO. Chlorine with hot NaOH would form NaClO3, sodium chloride 5. As the next part, PCl5 reacts with alcohols to form chloroalkanes. Identify the type of reaction. So alcohols turning into chloroalkanes, that's nucleophilic substitution. Okay, that's SN. Draw the structure of the organic product formed in the reaction of an excess of PCl5 with butane. The butane 1,3-diol. What is that? Bute कितने carbons है?
सर 4
Acha, 1,3-diol. That means one pair OH, and on the third one there's an OH. The rest are all H atoms. You can write the H atoms. The PCl5, what will happen is that the OH will get substituted by Cl. So that's it. That's your draw the structure of the organic product. That's it. ये वाला reaction है कि if you have an alcohol, so HCl, PCl3, PCl5, SOCl2, phosphorus plus bromine, HBr. In Salon what happens is it turns into a halogenoalkane. The OH is removed and it turns into a halogenoalkane. SCl2 is a cherry red liquid that reacts vigorously with water to form an acidic solution. Use the information to reduce the bonding and structure of SCl2. Remember, bonding में होगा covalent, ionic, metallic, etc. Right? Structure is either giant or simple, right? That's it. So firstly, based on the information that is given, what is the information that given?
सर reacts vigorously with water.
Huh?
सर reacts vigorously with water, तो इसका मतलब covalent हो जाएगा.
ठीक है. Remember, hydrolysis happens for covalent chlorides. कहाँ पे chlorides? वापस जाओ chlorides. ठीक है. Ionic dissolve. MgCl2, NaCl, they dissolve. Covalent chlorides, they react with water. ठीक है. So that is one hint that it's covalent. ठीक है. अब ये giant है या simple? वो किस पता लगेगा?
सर simple होगा.
अच्छा, ये तो पता लग गया कि it's a covalent chloride, right? As it hydrolyzes. नहीं, simple किस how do you know it's simple?
सर उसकी delta H formation कम है इस वजह से.
नहीं, उसका कोई ताल्लुक नहीं है इससे. Giant भी तो हो सकता है. We know it's covalent, right? How do we know whether it's simple covalent or giant covalent?
सर उसका हमें molecular formula given है इस वजह से.
वो तो SiO2 भी तो यही होता है ना. But it's a giant covalent structure, right? Simple or giant? How do you know simple? Simple ही, लेकिन how do you know it's simple? इसका क्या मतलब है? It's a cherry red liquid. What does that indicate? It shows that it's got low melting and boiling points. giant hota na, it would have high melting and boiling points. It's not going to be a liquid. A giant structure is never a liquid. So it's got low melting and boiling points. So why do you have low melting and boiling points? Because you've got a simple molecular structure. There's an SCl2 molecule, there's another SCl2 molecule, and they have weak intermolecular forces between them. So that's why it's a simple molecular structure. You clear?
So how does the color show that?
Not the color, the liquid part.
Oh.
Well, liquid, so that means it's low melting and boiling point, right?
Yes.
But अगर वो water का लिखता ना कि water, there's liquid water, right? So at room temperature. So I mean that indicates that it's liquid. That means it's got low melting and boiling points, right? So that's how we know okay, it's got weak intermolecular forces and it's going to be a simple molecular structure. So calculate the enthalpy change of formation of SCl2. What is the equation for enthalpy of formation of SCl2?
So सल्फर प्लस क्लोरीन होगा.
ठीक है, elements उसको मैं एसेट ले लेता हूँ, ठीक है. अच्छा, sulfur, I'm taking S8 because he's using sulfur as S8, ठीक है. So chlorine elements forming SCl2 liquid, state important है, ठीक है. This is a gas. Sulfur जो होता है, that's a yellow solid. अच्छा, so enthalpy of formation is that elements form 1 mole of a substance, right? So I would have to write 1/8 over here, right? If I want to keep this as 1 mole, then this would be 1/8. You clear?
Yes, sir.
Sure.
So now, so this is what you're finding. We want to find X, right? So, but the problem is I don't like 1/8. I don't like fractions. So what I'm going to do is I'm going to multiply everything by 8. Okay, fractions में deal करना थोड़ा मुश्किल है. So I'm going to multiply everything by 8. So basically, I'm actually trying to find out 8x. ठीक है? Is this clear?
Yes, sir.
Well, just getting rid of fractions. I don't want fractions in the equation. उसको handle करना मुश्किल होता है. So now you're given these two reactions, so you would have to construct. इसके अंदर you can't use a formula because there's just some random enthalpy of reaction. This is another random enthalpy of reaction, so you can't use any of the formulas. So you would have to construct a Hess cycle. You have to create a path that goes from one side to the other side. Okay, so you have to draw a Hess cycle in this case. The first reaction, S8 reacts with 4Cl2 to produce what? S2Cl2, right? So S8 reacts with 4Cl2 and produces 4S2Cl2 जो कि liquid है. But S8 only reacts with 4Cl2s. इसका मतलब है 4Cl2s are still left, right? Is this clear? I'm trying to connect the first reaction with this equation. I'm trying to draw the Hess cycle. So I wanted to find this enthalpy change. I'm trying to create this other route. So the first reaction was S8 reacts with 4Cl2 to form 4S2Cl2. The S8 reacts with 4Cl2 to form 4S2Cl2. So that means 4Cl2s are left. So is this clear, the first reaction? This is minus 58.
Yes, sir.
Yes, sir.
The second reaction, S2Cl2 reacts with Cl2 to form SCl2. That's this reaction, right? Lekin it is 4 times this reaction. It's 4S2Cl2 reacting with 4Cl2 to form 8SCl2. I mean, it's the same reaction. So this is what, minus 40.6 times 4 multiplied by 4 हो रहा है, ठीक है? Is this clear? तो हम पहुंच गए. We have made a product, right? So we've created this other path. Is this clear? It's not a question aayega na, I mean, this question is going to be difficult, okay? Where you have to like draw the whole Hess cycle from scratch. So, but is this clear, this part?
यस सर
Yes, sir.
सर हम लोग इक्वेशंस को ऐड अप भी तो कर सकते हैं
हाँ, वो दूसरा method था कि the other method was you could rearrange them and add them up. कि उसे कहा you may find it useful to use Hess law to construct an energy. So he's not forcing you to construct an energy cycle. So ठीक है, you can, in that case, you can do that. कि वो कर लेते हैं. The other method. This was the equation that you're looking for, right? Okay, so उसको directly ना मैं 1/8 ही लिख देता हूँ, ठीक है? So you were forming enthalpy of formation of SCl2, right? So you had S8, 1/8, plus क्या था? How many Cl2s? 1 Cl2, right? This was what you were looking for. And you had two reactions. So the first one, I wanted to make one SCl2, okay? So I'm going to write this first reaction. So reaction number 2, which is S2Cl2 plus Cl2, and it forms 2SCl2, right? This one. Again, I wanted to make one SCl2, so I'm going to divide this by half. इसको मैं half कर दूंगा. And this would, इसका जो 2 है ना वो हट जाएगा, ठीक है? The enthalpy change of this reaction would also be halved. Minus 40.6 divided by 2 हो जाएगी, ठीक है? Then I'm going to take the second reaction. The second reaction is S8. So I'm going to write the second reaction, which is S8. The first reaction number 1 plus 4Cl2, and it forms 4S2Cl2. Now in my equation, I've got 1/8 S8. So I'm going to multiply this by 1/8. So अगर इसको मैं 1/8 करता हूँ, so 4/8 would become half, and 4/8 over here would also become half. So I divided this by 8, so that means minus 58.2 divided by 8. You add up both these reactions, so you'll get this equation. But in दोनों को, if you add them up, the half S2Cl2 and half S2Cl2 will get cancelled out. Product side, you'll be left with SCl2. Half Cl2 will add up to be forming Cl2. So you'll get this equation, the one that you're looking for. So the enthalpy change would be the sum of these two things. Okay, that's the other method. So that, remember that it's your choice. There are two methods. Okay, you can either construct the Hess cycle, which we did over here. Okay, enthalpy of formation, find out anything. You found this. This was reaction number 1, minus 58.2. And this was the other reaction. One path is equal to the other path. So that would mean 8x is equal to minus 58.2 minus 40.6 times 4. And you solve for x. जो other equation add करने वाला तरीका वो ये वाला है, ठीक है? लेकिन दोनों cases ही मुश्किल है. ये वाला question जो है इसकी मैं अलग से playlist भी send कर दूंगा, ठीक है? Just make sure you're not going to get a big question on this. It's just going to be a 2-mark question, but जो drawing Hess cycle वाला question होगा, that's always going to be slightly tricky. ठीक है? But is this clear? ये clear है?
यस सर
Yes, sir.
चलो अब अच्छा next part is define the term structural isomer, ठीक है? Easy. अब वो देखो, वो 2 मार्क है, ये भी 2 मार्क है, ठीक है? फ्री के 2 मार्क्स है. तो remember this के बीच में ना, don't waste too much. मतलब इस तरह question है, especially where you have to draw the cycle, leave it till the end, ठीक है? It's going to waste a lot of your time because a lot of your question, but it's important that you finish the paper first, ठीक है? So what's a structural isomer? It's molecules having the same molecular formula but different structural formulas. Suggest a value for the CLSS bond angle in isomer 1. Explain your answer. So पहले तो कि CLSS this. Visha, आप बताओ कि how many lone pairs does sulfur have? It's in group 6.
Sir, it has 2. Oh, one only. One only.
It's in group 6. How many bonds is it making?
It's making
right?
2.
So it seems to be 2 bonded pairs and 2 lone pairs.
Okay, so if it's out of 6, if it's making 2 bonds, there are 4 electrons left, right? अब आगे बताओ कि if it's got 4 electrons left, so if it's got 4 electrons left, क्या shape होगी?
Bent V-shaped.
ठीक है, it's going to be V-shaped. Like he's asking for the bond angle. है the total 4, right?
Yes, sir. So is it 104.5?
ठीक है, it's going to be 104.5 because it's derived from a tetrahedral shape. That on 2 sides it's got lone pairs, on 2 sides it's got atoms joined together. So if it had 4 bond pairs, then it would be 109.5. If it's got 1 lone pair and 3 bonds, that's 107. But if it's got 2 lone pairs and 2 bonds, that's 104.5.
So can you also call it can you also call it bent?
You can
Or
call
just
it bent.
sheet?
You can call it bent. You can call it V-shaped, or you can call it non-linear.
Okay.
So then he's asking you to draw the Doran cross diagram of this molecule. So that's I think that's easy. Sulfur there's a sulfur in the middle, Cl, and there's another sulfur, right? Cl makes yeah, all the bonds are shown. It's making 1 bond. This Cl is also making 1 bond. Cl will have 6 electrons left. I said the sulfur and sulfur at the top are making double bonds. So that means let's all crosses. So it's making double bonds, right? So if sulfur makes a double bond, how many electrons are left? Out of 6, 2 are gone. So you're left with 4. What about this sulfur? Out of 6, 1 bond, 2 bond, 1 bond. So 4 electrons are gone. So you're left with 2 electrons. Oh. If sulfur is in group 6, so if it makes 1 electron over here, 2 shared over here, 1 shared over here, so that's 4 gone. So you're left with 2. Okay, is this clear?
Yes, sir.
That's a question number 2. They draw a label diagram of magnesium metal TK. So that's again metallic bonding. So that's a bunch of positive ions in a sea of mobile electrons, right? That's it. Shows identify the other products of reaction number 1 and 2. So what is Mg reaction number 1? Easy. Mg plus HCl. Kya banta hai? What's the equation?
Sir, MgCl2 plus HCl.
Nahi.
H2 gas. H2 gas.
H2 gas. Metal plus acid produces H2 gas. What's reaction number 2? MgCl. MgCO3. MgCO3 with HCl. What would that produce?
Sir, salt plus water plus carbon dioxide.
Because it's going to produce water and carbon dioxide. The other products. So water and carbon dioxide, H2 gas, water and carbon dioxide. State why calcium hydroxide would not form a precipitate with barium hydroxide. So he says in reaction number 3, a precipitate of MgOH2 is formed from MgCl2. Reaction number 3. Reaction number 3 here. Why do MgCl2 and calcium hydroxide form a precipitate? इन दोनों को mix करो, why do you get a precipitate?
So more reactive metal displaces the least reactive.
लेकिन यहाँ पे there is no metal. वो metal के लिए, not about metal ions. This is called ionic precipitation. If you mix two salts together, so you'll have Mg plus 2 ions, Cl minus 1 ions, you've got calcium ions, and you got OH ions, right? So your solution will have all these ions mixed together. Now, अब इनका apparently कोई reaction नहीं है. A salt does not react with a base. Like if you mix all these ions together, which two ions can combine to form something that is very insoluble? But in ions की कौन सी combination है that will produce something that's very or highly insoluble?
So magnesium hydroxide.
ठीक है, so magnesium hydroxide जो है ना, that will form a precipitate. This is known as precipitation. ठीक है, so it's going to form magnesium hydroxide. Calcium chloride will not form a precipitate because it's very soluble. Calcium chloride is very soluble. Chloride सारे soluble होते हैं. अच्छा, तो वो कह रहे कि why would calcium hydroxide not form a precipitate of barium hydroxide from BaCl2? तो बताओ कि if you mix calcium hydroxide with BaCl2, why do you not get a precipitate of barium hydroxide? मतलब आपके solution में ना calcium ions हैं, OH ions हैं, you've got barium ions, and you've got Cl ions.
So वो soluble हो जाएगा इस वजह से.
BaOH2 is soluble, right? So it's not going to form a precipitate. It would just remain dissolved. So soluble, it's not going to dissolve. So बस ये लिखना है इसका answer. 1 mark. Barium hydroxide is very, very soluble. State the type of reaction that happens. ये कौन सा reaction? Reaction number 4. Carbonate turning into oxide.
So decomposition.
Thermal decomposition, right? अच्छा, MgCl2 silver nitrate का test है. So what is going to be produced? Observed. What is going to be observed?
So white PPT of AgCl.
ठीक है. हाँ, मैं वो लिखने की जरूरत नहीं है कि this white precipitate is fine because observed ठीक है, is not. He's just no, but I'll come to the second mark. But he's just asking to state, not to explain what's happening, right? State what is observed, that's it. Followed by ammonia. What's going to happen if you add ammonia?
Sir, it will dissolve.
It will dissolve, okay? So PPT dissolves in ammonia. ये थोड़ा सा ना याद रखना कि what do these things mean, ठीक है? State means you just write what you just state, no explanation, ठीक है? यहाँ पे अब explain आ रहा है ना, so now you have to go into detail. Now you have to like fully explain everything. So MgCl2 is added to Br2. So what's going to happen?
So it's going to displace it.
Why would it displace it?
So more reactive displace कर देता है.
नहीं, लेकिन reactivity, what happens to reactivity down the group?
So it decreases. अच्छा नहीं, सही displace नहीं करेगा.
So no change, ठीक है? लेकिन अब यहाँ पे ना you have to like fully explain everything, ठीक है? Now you have to go into detail, you have to explain. Although it's just for 1 mark. What is the explanation for this?
So Br2 is less reactive than Cl2 because it has less tendency of gaining electrons.
How do you it's 1 mark? The explanation maybe we're not going to go into that much detail. So it's the Br2 is क्या लिखते हैं? Less क्या?
So less reactive.
हाँ, लेकिन don't use that word, ठीक है? Less reactive is not the correct word. Use this
Sir,
word.
electronegative?
No, not electronegative. For group 17 down the group, what do group 17 react as? मतलब,
So oxidizing agents.
ठीक है? So remember कि the elements are basically oxidizing agents, like fluorine, chlorine, bromine, iodine. They are oxidizing agents, right? So so the elements are oxidizing agents, so they become weaker oxidizing agents down the group. So what you're going to write is that bromine is a weaker oxidizing agent compared to chlorine. So जब भी बात हो ना reactive के, they're becoming less reactive. They're becoming less reactive as oxidizing agents. ठीक है, तो full लिखना. So Br2 is a weaker oxidizing agent. हाँ, अगर ये 2 mark का होता, maybe if you still have lines, you can further explain this, that it's a weaker oxidizing agent. Why does it? So it has a lower tendency to gain electrons due to greater shielding. Its nucleus is too shielded. ठीक है, clear है?
Yes, sir.
Yes.
अच्छा, फिर बस ये पहला हो गया, ये वाला हो गया. फर्स्ट क्वेश्चन जल्दी से. ये है प्रोटॉन न्यूट्रॉन्स, ये भी गलत किया तो फिर तो छोड़ ही दो पेपर. Relative atomic mass, what's the definition?
So mass relative to the mass of carbon-12 isotope.
नहीं. Partially ठीक है, you'll get 1 mark for this. It's the average mass of an atom. Average mass पहले लिखना. It's the average mass of an atom compared to 1/12 the mass of carbon-12 isotope. अच्छा, this one. The AR is already given. GA has 2 isotopes. ठीक है, both isotopes उनकी the masses are given. Now, so percentage abundance. So if this is X%, he's looking for the percentage abundance. So the other one must be 100 minus X%. So if one is 20%, the other one must be 70%, 80%, right? So you just have to find क्या formula होता है. It's a percentage abundance into the isotopic mass. So it's X times what, 68.926 plus 100 minus X times 70.925. Everything gets divided by 100. And that's equal to what, 69.723. So say you'll be able to figure out what X is. Is that clear?
Yes.
Achha, so why both isotopes of potassium have the same chemical properties? Why do isotopes have same chemical properties?
So same number of electrons.
उसको थोड़ा सा बेहतर करो. Say they've got exact identical electronic configurations, right? So state the full, ये बता दो, 19 electrons. So what's the full electronic configuration of this? That's क्या होगा? 1s2, 2s2, 2p6, 3s2, 3p6. Then there is 4s. क्या होगा? 1. That means 3d is empty, right? 3d is 0. So the first, second, and third ionization energies of potassium are given. Remember, potassium is in group 1. So based on this, why is potassium, by looking at these ionization energies, why is potassium in group 1? By looking at these,
Second
Because the one electron in the outermost shell.
okay, there's a huge gap between the first and the second, right? So there's a large increase in ionization energies from the first to the second, which indicates that the second electron is removed from an inner shell which is less shielded. So it's harder to actually move that electron. Okay? चलिए ठीक है, ये पेपर हो गया। यदि रोक लेते हैं, कल करते हैं, ठीक है? मेरे को पहले टाइम, हाँ वैसे बता दो कि क्वेश्चंस वगैरह कुछ चीज़ अगर।
सर आपने वो मोज की क्लास ली थी, उसमें सर आपने एम्पिरिकल फॉर्मूला का एक एडवांस क्वेश्चन करवाया था, वो अगर आपके पास वीडियो था आप उस शेयर।
मैं वैसे करा देता हूँ, बट वहां से उल्टा था, एम्पिरिकल फॉर्मूला ऑपोजिट डायरेक्शन में ना कि
यस सर, वो ऊपर पीछे रिवर्स लेके जाना।
वो ये था
सर
कि
मतलब पेपर, सर पेपर तक आप दो दो क्लासेस ले सकते हैं, मतलब एक सुबह और एक रात में।
हाँ मैं ले सकता हूँ।
सर क्योंकि मुझे ना मोज वाले क्वेश्चन में थोड़ा मसला आता है, वो जिसमें वो वाटर ऑफ क्रिस्टलाइजेशन आ जाती है।
ठीक है, खैर वो क्या पता इस दफा आ जाए दोबारा से, आ तो नहीं रहे मोल्स के क्वेश्चंस, बट देयर इज, उनका कुछ पता नहीं है, वो पैटर्न चेंज करते हैं, ठीक है? वो एब्रप्टली पैटर्न
सर
चेंज।
आप हर टाइप के
तो
से वो मोज वाले क्वेश्चन करवा दीजिएगा।
हम्म, नहीं ये
सर
वाला तो
जितनी
मैं, हाँ ये तो मैं करा दूं ना ये। एक सेकंड, क्वेश्चन सामने ही था, एक सेकंड का। तो कमर्शियल एनालिसिस का इनका पेपर 2 में बड़ा फेवरेट हुआ करता था, ठीक है? क्या खोल दिया उससे क्या, ये मोस्ट स्मिथ, वो गुम हो गया मेरे ख्याल से फिर से। हाँ ये था, हाँ ये वाला, ये था बस, वही है कि उसको ऑपोजिट डायरेक्शन में, ठीक है? यू गॉट ब्रोमीन रिएक्ट्स विद ए, तो उसने फॉर्मूला पहले ही दिया हुआ है, उसने रेशियो जो है ना वो पहले से कैलकुलेट किया हुआ है, तो फॉर्मूला इज AbR3, राइट? तो ए और Br की ना परसेंटेज कॉम्पोजिशन दी हुई है, लाइक दिस इज 4.31, द अदर वन इज 95.69, ठीक है? तो आपको पहले से पता है, यू ऑलरेडी हैव द फॉर्मूला कि वो 1:3 आना चाहिए, ठीक है? ही इज आस्किंग कि भाई ए की वो निकालो कि ए क्या है। तो हाउ यू फाइंड एम्पिरिकल फॉर्मूला? एम्पिरिकल फॉर्मूला इसके पहला स्टेप होता है डिवाइड बाय AR, ठीक है? तो डिवाइड बाय x, इसका डिवाइड बाय 79.9, ठीक है? और हमें पता है कि इनका जो रेशियो है ना, दैट्स गोइंग टू बी 1:3, वो फॉर्मूले से पहले ही पता है ना। एम्पिरिकल फॉर्मूला में यही होता था ना कि डिवाइड बाय AR करते थे और फिर यू गॉट द होल नंबर रेशियो, राइट? तो हमें रेशियो तो पहले ही पता है, तो बस वो क्रॉस मल्टीप्लाई करो, you'll be able to figure out what x is। समझ आया क्वेश्चन?
यस सर, सही समझ आ गया।
तो उसने वो जो आंसर था ना कि फॉर्मूला है क्या, वो पहले ही दिया हुआ था, उल्टा आपको पहली चीज पूछने को कहा हुआ था, ठीक है?
ठीक है सर।
चलो ठीक है, चलो ठीक है, वो कल कर लेंगे, वो वाला कर लेंगे, ठीक है? 12 बजे प्रॉब्ली एक रख लेते हैं क्लास, ठीक है?
सर 1 बजे तक हो सकती
तो
है वैसे।
1 बजे करना, ठीक है?
ठीक है सर, ओके, अल्लाह हाफिज़ सर।
अल्लाह हाफिज़।
Okay, thank you, sir. Allah Hafiz.